All right, TLDR, geometric series. A geometric series is a type of infinite series that follows the very specific rule that there's a common ratio you multiply by to get the next term. So here's an example of a very basic geometric series where I start with 1, and then I'm multiplying by 2 to get the next term, multiply by 2 to get the next term, multiply by 2 to get the next term. That's called a geometric series, and the ratio would be 2. I can write it this way using sigma notation. That would generate this series. So in general, we recognize an infinite geometric series as having this kind of form where you have a coefficient, you have a ratio raised to a power. That would generate this series, which a little trick, if you can factor the a out, and then you can throw it in front of the series. So a lot of times, just like with integrals, if there's a coefficient, you can move it in front. And you'll get the same exact solution as you would if you tried to find the sum of this one versus this one. Okay, so then I gave an example. And I said, does this infinite series converge or diverge? It's your job to recognize that it's geometric. There are two ways to do that. One, recognize the format and say, oh, look, I have the A, I have the R to the N, so this is geometric. Or if you can't, you can always expand out the series by plugging in terms and then recognizing, oh, look, to get from one term to the next, I'm just multiplying by a common ratio. So if that's the case and you recognize it's geometric, you find the ratio, which is 1/3. And then here's the rule you must know. If the ratio is between -1 and 1, the series converges. So if you have a geometric with r being 1/3, which is less than 1, we know that the series converges because the series is geometric with r equals 1/3, which is less than 1. Now, on top of that, if I know it's geometric and I know it converges, I can actually find what it converges to, aka the sum. So when I ask you what the series converges to, I'm asking for the sum of the series, basically the infinite partial sum. So to do that, believe it or not, we have a formula that is very nice and straightforward, and I will prove for you one day, I'm sure, just not in this video. You take the first term, always the first term, the first output, and divide it by 1 minus the ratio. So in our previous case here, the first term was 2, so that goes in the top, so it's right here. Divided by 1 minus the ratio, and the ratio is 1/3. So you do the math, and you end up getting 3. And that means if you were to sit there and do partial sums, your partial sums would get closer and closer to 3. So not too crazy. Here's one that actually alternates. If you notice, I expanded it out and I got 5 minus 10/3 plus 20/9 minus 40/27. This is an alternating geometric. And the cool thing about this is we just look at the ratio. It's -2/3. So as long as this ratio is between -1 and 1, so another way to write it is the absolute value of r is less than 1, we know the series converges. So plug into your sum formula and you can actually find what it converges to. Be careful about the double negative. It's minus a negative value, so it is plus. You can always test your answer by finding like the fourth partial sum and seeing if it's similar to your answer. It should be pretty similar. All right, then I gave two little kind of geometric tricks. The first one, this is not quite geometric. I mean, it is geometric, but it's hard to recognize what r is. So if you ever see exponents, remember your exponent rules. N plus 1 can be written as 4n times 4. And then we can rewrite it like this by putting the 4 as a coefficient. And now we have 4 and 5 to the nth, so we can pull the n out. And now it's geometric. And lo and behold, you can follow the math. The first term is 16/5. The ratio is 4/5, so I can find the sum. And I can find the fact that it does, in fact, converge because it's geometric with r less than 1. Here's another example. This kind of looks geometric, except the top doesn't have an n value, but it does, because if we see 1, we can write it as 1 to the n, because 1 to any power is just 1. And then I can rewrite it like this, and lo and behold, go from there. So geometric is going to be big. It's a crucial type of series to understand because it's going to pop up for the rest of this time and often pops up in FRQs in interesting ways. So as soon as you see the word geometric, you need to know that there is a common ratio to generate the series. And you need to know that you can, in fact, find the sum. When it's geometric and it converges, we can find the sum very easily by using this key formula. Super important formula. All right, that's it. Short one.